All right, guys, so this is 6.3. So we are headed into exponentials and logs, and we're probably going to do it for like 3 weeks, would be my guess. Who says, yeah, I don't really like logs so much? Raise your hand. Anybody in here? Okay, so I used to not like them either because it was confusing to me. Here's my summary of logs, you guys, I promise. It's like you've got all these rules, and you have to know the rules and apply them. That's all you have to do. Just know the rules and apply them to whatever situation it is. I really think you're going to be good. I think you're going to be fine. Okay, these two things right here are example of exponential functions, okay? They are both parents, okay? So look right here. This f of x equals a to the x. There's nothing added, subtracted. There's nothing up in the exponent. There's no negative, which means a reflection. And then the reason this guy goes up like that is because a is bigger than 1. Don't worry about the absolute value. They're just saying ignore the sign. You just look at the number part of it. If it's bigger than 1, it's going to swing that way. And if it's between 0 and 1, basically just less than 1, then it's going to swing the other way. Okay, so it's so easy to graph these. Okay, here's what you need to remember. Okay, first of all, on both of those, do you see the asymptote right there, you guys? It's y equals 0. Okay, and up in that box right there, you guys, I want you to write down the word parent. So both of these situations are the parent graph, and then we're going to start adjusting it. Okay, here's the other thing. You guys, it's not a race. I'm not trying to stress you out saying it needs to be a race, but literally I can graph an exponential, a parent, in like 15 seconds. It's super fast. So I just put down that asymptote, and then I always plot the point 0, 1, okay, and that's for both of those. And then I plot 1, comma, a. What's a? Well, that's your base. So look at this equation, or look at the top graph, guys. Do you see how it hit 0, 1? And do you see how they didn't really tell me the exact equation for that exponential? But look, guys, if you put your pencil at the origin, if you go right 1, how far up did you go? 2. So I know if they were to ask me, which they are not asking me, then I know my equation for that is y equals 2 to the x power. Okay, everybody look at the top graph and just shout it out. What's the domain of the top graph, everybody? All real numbers. Thank you for answering me. What is the range of the top graph, everybody? Greater than 0. You could also say 0 to infinity. You have to just make sure you close those with parentheses. Why not equal? Why not bracket? Yeah, it doesn't cross the asymptote. Yeah, it could cross it because remember we can cross a non-vertical, but in this graph it does not. Good. And then the y-intercept is always going to be 0, 1. You guys, you don't have to get really worried about does it go up on the right or down on the right, because if you follow these steps right here, it just naturally like falls right into place. That's why it's so easy. So right here on the second one, I want you to put 0, 1, and then I want you to put 1, a. And then I want you to add one more point, and that would be -1, 1 over a. Okay, so look at the graph and let me show you what I'm talking about. So you've got your asymptote at y equals 0. You've got your 0.01. If it's a parent, it's always going to be there. So look at the next one, you guys. If you go right 1, you go up. I don't really know what that is. So let's look at the other side. If I go left 1, I go up 2. Okay, so if they asked me what is the equation for this graph, which they are not, and they won't, I'm just trying to get you to understand it. If I go up 2, what's the reciprocal of 2? That would be 1/2. So that's what that equation is. Because I just go right 1, up 1/2, and I go, oh, go to the other side, left 1. What's the reciprocal of 1/2? That would be 2. Who says I understand that? Okay, look at the domain. Everybody in the room, shout out, what's the domain of the bottom graph? All real numbers. And what's the range? 0 to infinity, both with parentheses, right? And the y-intercept is still 0, 1. Okay, now I know that you guys know this, but I want you to just look for 2 seconds, okay? Just look, you don't even have to write this down. One of those graphs is a parent, the other one is not a parent. Which one's the parent? The one on the right or the one on the left? The one on the left. And then this guy has an up 3, he has a right 1, and he has a reflection across the what, everybody? The x-axis. Good. I just want you to know the difference between a parent and a non-parent for now, okay? So come right here. It's a parent graph, okay? It's a parent exponential. Watch how easy, okay? Literally 15 seconds. Look, I want you to always start with your asymptote. If you are missing the asymptote, you're going to lose a lot of points. So let's always start with that. Then you're going to plot the point 0, 1. It's always going to be there. Then you go back to the origin. It's not from that dot, guys. It's from the origin. And you go right 1 up, whatever the base is, which is a 2. That's enough. Curve it in, and I'm done. That easy. Okay. And then they want the domain, and they want the equation for the asymptote. Well, the red graph crosses the y-axis at 0, and the domain is everything, all real numbers. Now, let's talk about the table. So I think the table is lame because the point for the table is to help you graph it. Well, we've already graphed it, and we didn't need the table. So it's kind of like we're going in a backwards order. I'm not going to make you fill in a table. I don't think they're going to make you fill in a table, but just in case, let's fill it in, okay? So let's start with the 0 because it's so easy. 2 to the 0 is a 1. 2 to the first is a 2. 2 to the second is a 4. Somebody tell me what 2 to the negative first is. 1/2 is correct. What's 2 to the negative second? 1/4. Yep, pull it down. 2 squared on the bottom, that's a 4. Good. Okay, watch how nicely you can figure this out. Okay, watch, guys. First of all, it's a parent graph. The second I know it's a parent graph, I'm going to dash in that asymptote. Some people will draw the asymptote above the axis because they're like, oh, if I put it right on there, you can't see it. Do not move it up because and then it's inaccurate. Just extend it and so I can see it. Or better yet, use something red and extend it, right? Okay, it's a parent 0, 1. Listen to the reasoning that goes on in my head, okay? Pencil back of the origin. I go right 1 and then up the base, which is a 1/2. And then this is what I say to myself. That's weird, it's lower. I go, oh, well, that's okay. If it's lower, I know the other side's going to be higher. So I go left 1, then I take my 1/2, I flip it upside down, I curve it in, and it's that easy. Okay, who says gotcha? Oh, you guys okay? Okay, good. You were writing. You can't write and raise your hand at the same time. You guys need to raise the other hand. Okay, so domain is everything, and the asymptote is still going to be y equals 0. Okay, let's look at the table. 1/2 to the 0 is a 1. 1/2 to the first is a 1/2. Can you guys tell me what 1/2 to the negative first power is?
2.
That is a 2, yeah. It's a 2 to the negative first on the bottom. Pull it up, it's a 2 to the positive first. Everybody in the room, how about 1/2 to the negative second?
4.
That's a 4, good. Okay, let's do the next one. Listen for 2 seconds, just freeze. You do not have to say this. Don't let this even come in your head. Is this the one where it swings up on the right or swings up on the left? You don't even have to think about that. It just happens naturally. So don't get too worried or, consume your time with that much at all. This is what you do. I got a parent, dash it in, extend it beyond the axis. Since it's a parent, I know it's going to hit 0, 1. Pencil back to the origin, right 1, up 3, it swung up. I don't have to find that third point. Done. That easy. Okay? Okay. Raise your hand if you're like, I'm totally, completely fine. Give me feedback so I can see. Okay, awesome. Okay, the domain is everything. The asymptote is y equals 0. Fill in the table. 3 to the 0 is a 1. 3 to the first is a 3. Everybody in the room, what's 3 to the negative first? 1/3. Good. Okay, easy. Now we're going to start adjusting it. Okay, so let's do this. Everybody write this down. Write y equals a, and then in parentheses b, and then I'm going to go x plus c plus d. Okay. It looks like I'm just kind of throwing them at you without much explanation. So I want to give you a little explanation. Draw an arrow to the D. That would be like, see an example C, see the -2 right there? That D would tell me to go where, guys? Up or down. Yes. So let's go up or down. Positive means up, negative means down. Now draw an arrow to the C. The C tells you to go where, guys? Right or left. But remember this, the X lies. So it's the opposite of what you think. So if the middle sign is a plus, you go left, and if it's a negative, you go right. Okay? Now, put something in front of A, draw an arrow in front of A. So I'm not talking about the sign of A, I'm talking about the number A. That's going to be a what or what? It's going to be a stretch or shrink. Yep. So it's going to be stretch if A is greater than 1. It's going to be a shrink if A is less than 1. And I'm not talking about the sign. Okay? I'm going to do one more thing. If I put a negative in front of the A, draw an arrow to that. If the negative is in front of the base and the exponential, then it's going to be a reflection across the, tell me everybody, the x-axis. Yep, if it goes there. And then one more thing, I know I'm squishing this all in, put a negative in front of that. And not to be too technical, but you'd actually have to have parentheses around the x plus c. Don't let that freak you out. Draw an arrow to the negative, and that is actually a reflection across the y-axis. So if it's up in the exponent, it's y. That's all you need to know. Okay. Question 3. You guys, Weber State, listen what they used to make us do. Draw the parent with an explanation and an equation. One transformation, explanation, equation, next transformation, blah, 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 blah. Now they just say, give us the parent, give us the final graph. So don't complain about doing the parent because it could be way worse, because it has been way worse. Okay, so the first thing I want you to do is to graph the parent, which is y equals 3 to the x power. So since it's a parent, I have an asymptote right there. It's going to hit 0, 1, back to the origin, right 1, up 3. There's my graph. The negative, everybody in the room, what does the negative do? It reflects it, right? Across what? Don't look at the directions, just remember. It's the y-axis, correct. Okay, so look what's going to happen to the asymptote, you guys. Look, here's your y-axis right here, okay, highlighted in green. So the right side of your asymptote is going to lie on the left, and the left lies on the right, so there is no change in your asymptote. So I always start there. That 0.01 also does not change. And the 1,3 comes to the other side, and it just swings, and it looks like that. There's my answer. That's it. Okay, next question. Everybody start with the parent, which is y equals 2 to the x power. So grab your pencil, dash in the asymptote. It hits 0, 1. From the origin, right 1, up 2. There's your graph. Looks like that. Everybody talk to me about that -3. Just shout it out. What does it do to my graph? Moves it to the right 3. Guys, look right here for 2 seconds. Look at my arm. If I have a horizontal asymptote and I move it to the right 3, have I changed my asymptote? No. So it's still going to be exactly the same. Every single graph I draw, I start with the asymptote. 2 reasons. So I don't forget it. And number 2, so I have guidelines. So I know what I can't cross. So here I am right here at 0, 1. If I go right 3, 1, 2, 3. Here I am at 1, 2. And if I go right 3, 1, 2, 3, there it is, curve it in, and I'm done. Okay? Okay, next one. Everybody write down y equals, in parentheses, 1/3 to the x power. What if I didn't put parentheses around it? Look right here for 2 seconds and just listen. What if I didn't have parentheses around it? Would that be acceptable? What do you think? Yes. Stop writing for just 1 second. Okay? Would it mean the same thing if I didn't have parentheses? Yes or no?
Yeah.
The answer is no, it wouldn't. Does anybody have any idea why? Which is the 1, yes. If I didn't have parentheses, the only thing raised to the x power would be the 1, and they're both supposed to be raised to the x, so I need the parentheses, okay? Okay, we've got a parent, guys, so dash it in. 0, 1, back to the origin, right one up a third, and then I go, okay, it's going to swing down, so 1/3 flips upside down is 3/1, so if I go left 1, I go up 3, curve it in, there's my parent. Everybody tell me what the -2 does to that graph. Down 2. Talk to me about the +1, everybody. Left 1. If I have a reflection, everybody write this down. Write down, reflect first. If you have a reflection, you must reflect first. We don't have a reflection. But if you do, you must always reflect first, okay? Okay, if I move that asymptote left 1, it doesn't change it, but if I move it down 2, it does change it. So there's my asymptote. I'm going to put my point at 0, 1. I'm going to go down 2 and left 1. Then I'm going to go to this point because I feel like it's clean. I'm going to go to left 1 up 3, and then I'm going to go down 2 and left 1, curve it in, and there we go. That's it. Okay, in question 3C above, so that's what we just did, what is f of 0? You guys, look right here. They're asking me about this graph because that's my solution graph. That's my actual graph. What is f of 0? Well, they're asking you, write this down for me, okay? If x equals 0, what is y? That's what they're asking you, okay? So look at the graph. If x is a 0, that's not a clean point. I can't say like -1.6 or something like that, okay? So go to the equation. Everybody go, f of 0 is equal to, in parentheses, 1/3 to the 0 plus 1 minus 2. Well, 1/3 to the 0 plus 1, that's just 1/3 to the first power. So what I really have is 1/3 minus 2. Let's think about this. You can do this in your head. I have to subtract those numbers because the signs are different. What is 2 subtract 1/3, everybody? I have 2 full pizzas and I lose 1/3 of one of my pizzas. How many pizzas do I have left? 1 and 2/3. Only the sign is going to be a what, everybody? Negative. Yep. So that's the resulting point, okay? Or that's the f of 0. What is the resulting point? Well, in x is 0, y is a -1 and 2/3, and that's my second answer. So I don't write it as a point until they say point, okay? All right, question E. In question 3C, if f of x is -1, what is x? Okay, so underneath that, write this down, okay? If y equals -1, what is x? Okay, so look at your y value of -1. You guys, I'm talking right here. Don't do this to your paper, but look right here. If y is a -1, what's x? Well, that's a clean point. So that ordered pair right there is -1, -1. So if y is a -1, what is x? The answer is x equals -1. What is the resulting point? -1, -1. Those are those 2 points. Okay, yes, honey?
Question D. Would it be acceptable to write it as -5/3 instead of 1?
Yes, yep, same exact thing, honey. I just wrote it. I never write it as like -1 and 2/3. I always write -5/3, but it was just so easy to do in my head. That's why I did it that way. Okay? Okay, who says this? So far, so good. Raise your hand. Let me see. Okay, good. Okay, I want to talk about E. You guys know pi. You guys feel very comfortable with pi. It is 3.14159, right? E is just like pi. It's exactly the same idea as pi. It's this number. It's irrational because it doesn't end and it doesn't repeat, and it just has a constant value. Literally, that's all you have to know for this class in terms of what E is. Just remember 2.7, okay? So let's graph this, Okay, so everybody write down y equals e to the x, and that's my parent. So you always want to start with the parent. Okay, so dash in your asymptote. It's always going to be the same. Plot the point, 0, 1. Back to the origin. Write 1 up. Somebody shout out how high up I go. 2.7, because that's my base. That's my e. Curve it in. There's my parent. And now I have to adjust it. Everybody tell me what the -3 does to my graph, everybody. Down 3. What do I always graph very first on every graph? Tell me. The asymptote, yes. Does moving that asymptote down 3 change the asymptote? Yes. So I'm just going to go like this. Then I'm going to go to those points. 0, 1, down 3, 1, 2, 3. 1, 2.7, down 3. I'm just a little bit below the x-axis right there. Curve it up, and there we go. So if you guys, so I worked like 50 hours last week. Actually, considering that I worked like 6 hours yesterday, I think I worked 60 hours last week. And sometimes I'm at these, we were stayed at these rubric meetings, and I wish you guys could hear the conversations. And so they just talk about things like this. Look, like if you do this to your graph, and then you go like that, how many points are they going to give you?
0.
They will give you 0 points, okay? So you just have to be so careful. You know the rational function question that was on your test, horizontal asymptote, all that stuff? Your guys' y values were very inaccurate. Like almost every one of my 1050 students, it was like you're supposed to go left 2 and then you're supposed to be clear up at a 6, and you guys were like at 4s or 3s. And so I was afraid they were going to annihilate us because our y values were not correct, and they did not care about that. So everybody got that right even though your scale was off. And so just be careful, you know, like maybe plug in a 3 and plug in a 2 and kind of get an idea of where you're supposed to be, because you guys were way off on the midterm. But thank heavens they didn't do that to us, so they didn't get us. Okay, question 5. Here's your graph, okay? Here's your equation. First of all, it looks so bad. Somebody tell me what looks bad.
The 4.
The 4 should be like where, so I don't feel confused. Put it at the end. So everybody go negative e to the x minus 3 plus 4. Why did I make the e a negative? Because right in front of it is a negative. Why did I make the 4 a positive? Because right in front of it is a positive. Okay, so question A, I want you to write the word skip. Question B, I want you to write the word skip. So you're skipping those until you graph it. Okay, so the first thing I always want you to start with is the parent. And you guys, here's the parent. Look right here. See your base and see your x. That's how you find your parent. It's always the same base, and it's just to the x power, okay? So let's graph that. So I'm going to sketch it in. I'm going to plot 0, 1. I'm going to go right 1, up 2.7, curve it in, and that's all I need from you, okay? Now, let's list our transformations. This is important, so I want you to really listen. Everybody shout out. Tell me what the plus 4 does.
Up 4.
Up 4. Okay. Tell me about the minus 3. More than just one person, guys. What does the minus 3 do?
Right.
Right 3. Are those my only transformations?
No.
What else do I have? The negative, which is a reflection, right? Is it a reflection across the x or reflection across the y?
X.
It is the x, okay, because it's at the front. Okay, everybody freeze right here. This is huge. If you don't know what I'm about to say, you will literally lose every point on this question when it comes up on the final, okay? Of those 3 transformations, what must I do first?
Reflect.
You must reflect. So right here, I want you to put reflect x. I want you to erase it from there. So listen carefully. If there's a reflection, you will have a separate graph, which is the second graph that is just the reflection. And then the other transformations can all be done in the third graph. Freeze for 2 seconds. I want to ask you a question. Why do I have to reflect first? Why do I have to reflect first? So, who said that? What are you talking about? I know you know what you're saying. The order of operations tells you that you have to multiply before you add and subtract. So that's why you have to do the reflection first. Who says gotcha? Okay, let's reflect that guy across the x-axis, okay? So it does not change my asymptote. It's going to just reflect across itself. The 0, 1 comes down to 0, negative 1. The 1, 2.7 comes down to 1, negative 2.7. And there's your graph. Now you take that second graph and move it up 4 and right 3. So take the asymptote and shift it up 4. There it is. So we're here at 0, negative 1. Go up 4, 1, 2, 3, 4, right 3, 1, 2, 3. Take the other point. So this is just a little awkward because it's not like a precise point. We're at 1, negative 2.7. So we're going to go up 4, 1, 2, 3, 4, and then to the right 3, 1, 2, 3. There it is, curving in. Okay, I want to show you something, and this is going to help you. If you guys can do this to your graphs, it's going to help you. Look right here. When I grade this, I check the points, but I also check the stretch. Let me show you what I'm talking about. See right here, the stretch. I went right 1, right here, and then I went up. I think my graph just tweaked. It did. I don't know how I did that. It's okay. Don't worry about what my graphs look like. My PDF moved and my graph didn't right now, so it just tweaked all my graphs. Who says I understand what you're saying? No idea how that happens, but anyway, see how I go right 1 and then I go up about 1 point, whatever that is. I think it might be 1.3. If you come over here, do you see how I have 1 and then I have about that same stretch? So I'm just checking to make sure your stretch is consistent between those points. That's how I eyeball it to see if you're good. Who says I understand what you said? Okay, good. Okay, let's do this one. So we've got a piecewise function, and they want you to graph it, okay? So everybody write down y equals negative 2 to the x power. I want you to sketch an xy axis right there, and I want you to sketch in the parent, okay? So just dash it in, and then you've got 0, 1, and 1, 2, and there it is, okay? And maybe right underneath it, just write down y equals 2 to the x power. Then you have to take that 2 to the x and you have to reflect it across the x-axis because of that negative. Okay, now I'm going to do it on my real graph. So reflecting doesn't change the asymptote. The 0, 1 comes down to 0, negative 1. The 1, 2 comes down to 1, negative 2. And now my graph looks like that. Okay, but that whole graph is not supposed to be there. The only values that are supposed to be there is when x is less than 0. So guys, that would be to the left. So all this stuff to the left stays, and the stuff to the right goes away. So this goes like this, okay? And I do not have an equal sign, so I have to take that circle, and I actually have to make it an open circle like that, okay? Okay, now write down the next equation, which is y equals negative 2 to the negative x. So that's a double reflection. Reflect x and then reflect y. So let's just go on this graph right here, guys, and reflect it across the x. So there's an x-axis reflection. Okay, I'm just doing it so I can see it. It's right there, okay? Now I have to fold that guy across the y. Well, it's not going to change the asymptote. The 0.01, I'll do this in, I'll do it in black. The 0, 1 is still there. And then this right here was 1, 2. And so now it's going to be over here, negative 1, negative 2. So it's actually going to curve like that. Okay, so that's what it looks like. They don't want the whole thing. They only want where the x values are bigger than 0. Well, that's to the right. So anything to the left, I have to get rid of. Okay, so it looks like that. Now, what did we say before when a closed circle intersects with an open? Is it closed or is it open? Closed. It's closed. So this is a closed circle, and it looks like that. Some of you have already flipped, and we're not done yet. Okay, find the domain and find the range. Somebody's hand went up. Who was it? Yes. Go ahead and freeze for 2 seconds, guys. Go ahead.
On number 5, you had to skip 2 problems and didn't go back and do them.
Okay, I'll go back in 2 seconds. Okay, let's do the domain. Everybody look at the domain. Go from left to right. Everybody tell me what it is. All real numbers. And the range, let's do it in interval form. What is it, guys? -1 to what? To 0, right? How do I close my -1? With a bracket. Why a bracket? Because it touches it, right? And how do I close my 0? Parenthesis. Parenthesis because it's never going to touch it, right? Okay, so come up here. Oh, yeah, we skipped them. Haha, thank you for saying that. Thank you for saying that. Okay, go back to this one. Now that we've graphed it, let's find the domain and range. So everybody look at the final graph. Domain is, tell me everybody, all real numbers. Find the intercepts. So you guys know from that quiz or test that I was really strict with you guys that you labeled those, and if you didn't, I took points off. So look at the x-axis. Now, it looks like 3, but I'm not convinced it's 3, so I'm just going to wait. I'm going to let y be a 0, and then I'm going to let x be a 0. Okay? And they both look like they could be ugly. I'm not super convinced that they're clean, meaning like 1, 2, 3. So let's put them in. To find the x-intercept, let's do the easier one. Let's let y be a, let's let x be a 0. So everybody go y equals 4 minus e to the 0 minus 3. Well, that's just -3. Now, they're not going to want a decimal representation. So let's write it like this. Let's write down y equals 4 minus e to the -3rd. And then let's pull that e to the -3rd down. So it's 1 over e to the 3rd. And so I'm going to leave it right there. Okay, so we're going to say that the y-intercept is 0, 4 minus 1 over e to the 3rd. And that is an exact answer. Write down the word exact. Exact means I didn't round it. Okay, let's do the x-intercept. To find the x-intercept, you're going to let y be a 0. So go right here and let y be a 0. So 0 equals 4 minus e to the x minus 3. Now, we haven't talked about solving exponentials, but I know you guys know how, so we're just going to do it. If this freaks you out, don't worry, we're going to go through it, okay? Solve that. So move, I'm going to take this negative e to the x minus 2 over there. So that leaves me e to the x minus 3 is equal to 4, okay? And then I want you to write the word stuck. Now we're stuck because I've got my base and I've got my exponent and I don't have anything else over there. There's no number in the front. There's no number added or subtracted. I'm just stuck. And when I'm stuck, I convert, okay? You're going to hear that a lot in the next 3 weeks. When you get stuck, convert it. So it's in log form, or it's in exponential, so I have to convert it to log. So I get log base e of 4. Okay, I'll just write it as log base e of 4 is equal to x minus 3. Pull your 3 over and it becomes a positive. You guys, what's another name for log base e?
Natural log.
ln, yes. So that's going to be 3 plus the ln of 4. Is what x is. So I pulled my 3 over, it became a positive. So it's 3 plus the ln of 4, okay? If that confused you, don't panic, okay? I promise we'll go through that better. So it's 3 plus ln 4, so I'm going to write it as an ordered pair, and that's it. Okay? All right, let's move on. Now we're going to solve these exponentials, which is pretty much what we were just doing. Okay, but these ones are different because we're going to find a common base. Okay, so look at 1, you guys. The 3 is the base. So I have 3 to the x plus 1 is equal to 3 to the something. I want a common base. Does anybody know 3 to the what is 81? What is that? 3 to the, it's not first, right? It's not second. What's 3 to the third? 27. 3 to the 4th. Okay, now watch this. If 3 to this equals 3 to that, then those things must be the same. It's not like 3 squared is going to be equal to 3 to the third. They have to be the same. So now I know that x plus 1 must be 4, so I know x must be 3. Is this problem checkable? Tell me that.
Yes.
I can check this thing in 15 seconds. I'm not exaggerating. Look at the left-hand side. 3 plus 1 is 4. Is 3 the fourth? 81. Check. That quick. Plug it back in. Okay? Okay, this one right here. This one's tougher. Okay? On the bottom, you have a 5 to the first. I need my bases on the same level, you guys. So this is a 5 to the x plus 3 is equal to 5 to the, can anybody tell me? It is negative first. If it's a positive on the bottom, when you pull it up, it becomes a negative. So now I know this exponent must be equal to that exponent. So I know x plus 3 must be negative 1. That gives me x equals negative 4. Okay? Every person in the room, grab your calculator. Okay? When you take quizzes and tests and your final, you want to check every single thing that you can check. Does anybody know what 1/5 is as a decimal? Just add it in their head. It's 0.2. So everybody do this. Go -4, store, enter. Then put that left-hand side that I just circled in your calculator. But you have to be careful, guys. You have to go 5 to the, tell me what the very next button is I have to push. Parenthesis, yes, because I've got 2 things in there. And then I go membar, enter, plus 3, close it, enter. I got my 0.2. I know I got the problem right. I would do that on quizzes and tests for sure. Okay? Okay, right here, common base. People mess up on this. Okay? This is a sore spot. When we get some time, I want to take your workbooks out and have you highlight the things that are on the final. And I think this right here was on the final last semester. And it was a sore spot. Okay, here's what you do. 5 and 125. Okay, over here out to the side, write down change the big number. You don't change the small one. You change the big one. So look what we're going to do. You write it as 5 to the x squared plus 5 is equal to something to the 2x minus 1. So I didn't change anything. I wrote everything down exactly the way it is. I just didn't write the 125 down. I want to write the 125 as a 5 to the something, because then I can get my bases the same. 5 to the what is 125? Do you guys know? It is third. Good. Now, I can't have those parentheses over on the right-hand side. So the left is still just going to stay the same. And then on the right, I have 5 to the, what do I do to my 3 and my 2x minus 1? Do I add or do I multiply? Multiply. So distribute, and you get 6x minus 3. So if 5 to this equals 5 to that, those things must be equal to each other. So x to the second plus 5 must be equal to 6x minus 3. In the past, you guys are so smart. So I don't think I would have this problem with you. In the past, I've had people like move the 5 to the right and then square root. Why can't you do that? You're going to get a plus or minus answer, but even more importantly, listen to me, guys. If I move my 5 over to the right and then square root, I've got an x equal to some kind of an x. I can't do that. So what do I do right here? Put them all on one side and then do what? Then factor. Good. So let's do it. So let's go x to the second minus 6x. The 3 comes over and becomes a positive equals 0. And then I factor, so it goes to x and x. Signs are the same, they're both negative. 4 and 2 multiply to give me 8 and add to give me 6. So I get x equals 2 and x equals 4, and I'm done. Can I check these, yes or no?
Yes.
Yes. Who says, I feel like I know how to check these? We don't need to go through it together. Okay, good. Just please do that, okay? Okay, question D. Who do I change, the 5 or the 25? Everybody tell me.
25.
The 25. So this is a 5 to the what is that? It is 1/2. Good. Square root of 5 is 5 to the 1/2. Then see the 25, I'm just going to omit it. And then I'm just going to keep the x plus 2. 25 is a 5 to the, tell me, second. So now I have 5 to the 1/2 is equal to 5 to the power to a power you multiply 2x plus 4. So now I have 2x plus 4 is equal to, you guys, it's a 1/2. Is it okay if I put 0.5?
Yes.
It is okay. Why is it okay?
It's clean.
Because it's clean. It's exactly the same. If it was 1/3 and I said 0.3, no way. Okay? Move your 4 over, and I get 2x equals negative 3.5. Divide by 2, and I get negative 1.75, and that's my answer. Done. Who says this is easy? Raise your hand. Let me see. Okay, great. Okay, question E. The bases are already the same. So this gives me e to the 3x squared is equal to e to the 15th. People say this and it makes me crazy. The e's disappear. Do the e's disappear?
No.
No, you've evaluated it. And you know, therefore, those must be the same. So please don't say things disappear because math is not magical. It's just you evaluated it, okay? What do I do right here? Should I square root right here, guys?
No.
What do I do? Divide by 3. So I have x to the second is equal to 5. What do I do now? Square root. And I get x equals, what comes right after the equal sign? Plus or minus. Why did you add the plus or minus? It's because you did it, right? So it's plus or minus, square root of 5. We're done. Completely checkable. Okay? All right, question F. It's taking, oh, there we go. It's taking a second to clean up. Okay, look at this problem. Just freeze right here. Let's do it together. What are the two bases that I'm looking at? The base on the left is a what, everybody?
2.
A 2, and what's the base on the right? And it's an 8, okay? Which one's the big one? The 8. So that's the one I'm going to change. So I'm going to leave my 2 to the 3x alone. And I'm going to take my 8, and I'm going to write it as a 2 to the, talk to me, everybody. 2 to the third, right? 2 times 2 times 2 is 8. But I can't have that one on the top and one on the bottom. So let's pull them both up to the top. So now I have 2 to the 3x is equal to 2 to the, talk to me, everybody. Negative third. Yep. So 3x must be negative 3. Therefore, x must be negative 1. And this is a 15-second checker. Look, left side, 3 times negative 1 is negative 3. 2 to the negative third, pull it down, 1/8. I know I'm right. You can check it in your head if you want to. Okay, question G. Which one do I change, the right or the left? Talk to me.
Right.
The right. So this is a 5 to the 2x, and the right is a 5 to the, talk to me. It's a second. Now pull it up. So 5 to the 2x is 5 to the negative second. So 2x must be negative 2. Therefore, x must be negative 1. Who says I get this? Raise your hand. Okay. This, you guys, exponentials are so closely connected to logs. Super close. One more example and we're done. And then you guys can focus on your other classes for a few minutes. Okay, example 8. The normal healing of wounds can be modeled by this equation, where A sub 0 is the original area of the wound, and A describes the area of the wound after n days. Suppose a wound has an original area of 100 square millimeters. Okay, when you have an ugly word problem, guys, I always want you to write x equals y equals. I know there are no x's and y's in the equation, but you think in terms of x and y. So it's solve for A sub n. And then you read, what does that mean? It's the area. So the y is the area in millimeters squared. And the x, hi, come on in. Oh my goodness, you guys look.
I have a spot.
Oh my gosh, hello. You're so beautiful. You're a what?
Spy.
A spy? Because we can't see your face?
Now I'm ready to see my whole costume.
Well, it's beautiful. You should let him. You guys look so lovely. Oh my gosh, there's a monkey. Hi, monkey.
Cat.
Hi. Do you guys need candy? I didn't know. I mean, I
This is
knew
a
you were
clown.
around. Someone sent me an email, but I didn't really read the date. But I'm ready. I'm prepared.
Nope, for higher.
Okay, so I have spider rings too. A spider ring. Who wants to help me? Will someone raise up?
I know
Who
you
wants to help me the most? Okay.
I do.
Oh, she's gonna. Shoot, you can help her. Okay, yay! Everybody's always. And here you want candy?
So good. Let's get some candy. Say trick or treat.
People watching this video will be so
I think you need two. You need two? Yeah, we have two. Because you're a cat, and then they'll be happy to run another There's a ring too, but maybe the other one should come with a ring. This one needs a ring. Oh my God. What do you say, Lucy? Here. No, let it come in. Oh, right here.
I did this. I fell asleep and I had like usually I'll just like make it like that, but I just make my can right here with my pencil in it.
Did they just keep
I'm so nice. Oh, thank you. You're so sweet. So I got the email you guys were coming. I'm like, oh, I'll get it. But I guess I just assumed it would be Halloween. I didn't read. Stephanie Fitz. Yes, yes. You already have her. Oh, that's so good. Oh, my daughter dances with my daughter. Yeah, so I know her pretty well.
And then Zach, he takes two of them.
Oh, who is?
Zach. The son Zach.
Oh, is
Stephanie's son.
Is what?
Like up to here.
Would you like a spider ring?
Don't eat it. It goes on your fingers. Okay, thank you. I have a little bit more candy for you guys if you want some. Yeah. Duh. Aren't they so cute? Like some of them were like starting to cry. Who wanted a ring? Who else wants a
It's
ring?
gonna be like an hour and a half long video.
Anybody else want a ring?
Everyone wants a ring.
Everybody, there's more.
Everybody wants a ring.
I have like 10 more.
Should I make an earring? I did a ring.
I'll check that. Who else wants a ring? Anybody? Okay. Here's another one. We guys pass that back.
I'm scared. Is that earring?
There's like more.
Should I make it an earring?
Okay, think how horrible if I wouldn't have got my candy yesterday. I
Okay.
didn't see my email and I was, oh yeah, they're coming on Halloween.
She would have been
I was
fine.
gonna tell you guys and then, you want a ring?
All you kids are
Anybody else? They would have cried. I would have been so embarrassed. Yeah.
got that eyes.
And keep passing it out to others. Okay, you're welcome. Okay, you good? They're so cute. I really was afraid that the little one could eat their rings. I'm like, I don't know if you should give them to like them. 1 and 2-year-olds, they'll eat them. Okay, let's finish. That was cute. Your guys' reaction was so cute when you came in. They were like, oh, look. I love little kids. Okay, so anyway, back to example 8. And then x is represented by n, which is the number of days. Okay, and then they tell you that a sub 0 is where you begin. So everybody write a sub n equals 100 e to the negative 0.35 times n. So here's the scenario. You get hurt, you've got this wound, and then the wound starts healing. So the wound is getting smaller. What in that equation tells us the wound is getting smaller? The negative for the rate, right? So how large will the wound be after 3 days? So you just go a, that's an n value. So it's a sub 3 is 100 e to the negative 0.35 times 3. So grab your calculator, 100. Grab your calculator because I need you to see where to access that value of e. So go 100 second ln, that's 2 buttons down. And then notice the calculator already puts the parenthesis. So you go negative 0.35. You guys see how the 3 right here is in parentheses? I never do that. I know it means multiply, so I just go times 3. Close it, hit enter. And we're going to go, they'll tell you where to round. I'm just rounding 3 digits. So you don't determine that. That would be told to you in the directions. So it'd be 34.994 square millimeters. Make sure you label. How large will it be after 10 days? So that's a sub 10 is 100 e to the negative 0.35 times 10. You guys, I am a big fan of storing these numbers in. So let's all just go 10, store, enter, and then go 100, second ln, negative 0.35, membar, enter, close it, enter. And again, we'll say that the directions told you to round it 3 digits. So it's 3.012, and that would be square millimeters. That's it. Okay, who says got it? I feel good, I'm great, everything's fine. Okay, great. Okay, so we don't have quite as much time as I thought we would, but we still have about, I don't know, maybe 15 minutes, 12